Hey people, let's suppose we have to buy a new iPhone. Typically, we will go to our nearest store where iPhone is available, search for the relevant model, and go to the billing counter. But wait, they have removed the charger and the earpods. So if you want to buy a new iPhone, you will buy a new charger and a new AirPod. Today, the goal of any organization is to increase their profit and their revenue. Can this be done by pitching one product at a time? Answer to this question is obviously no. So organizations started mining the data about frequently bought items. They try to figure out if an item A is bought, then what is the chance of buying the item B in the same transaction, where A is an antecedent and B is an consequent. Point to be noted is that these values don't depend on the coincidence of a transaction, but rather the co-occurrence. Association rule mining is all about building rules, and we have just created a rule. Now imagine for a large supermarket or a store where there are large number of items, how many rules we have to create. These type of single cardinality rules don't work when we handle large data set. Suppose if a customer who bought A and B also wants to buy C, then cardinality will increase proportionally. This can create a problem with large data sets. We have three types of matrices which helps us to understand the association between these items. Support is the frequency of item we have bought or the combination of the frequency of the item we have bought. With this, we can filter out the items which are bought less frequently. There is another measure which is called confidence. It tells us how often the item A and B are bought together. In a large dataset, we can have too many values of support and confidence, which can lead to a big mess. So, there is a third measure which is called lift. It basically tells us about the strength of the rules. Now let's have a look at the denominator of the formula given here. As you can see here, we have given the independent support values of A and B. This gives us the independent occurrence value of A and B. This helps us to eliminate the results due to randomness. So if the denominator of the lift is greater than the numerator, this means the randomness of occurrence is more than the association. Now let us understand it with an example. Given a set of transactions, association rule helps us to find rule that will predict the occurrence of an item based on the occurrence of other item in the same transaction. In the given example, customer 1 bought bread and milk, customer 2 bought bread, diaper, beer and eggs, and so on. These type of transactions are called market basket transaction. It consists of two parts. First is transaction ID of the customer and second is the list of item bought by a customer. In large supermarkets, this kind of data will be definitely huge. In late 80s, a research group at IBM saw a pattern in such data. They saw a definite association between a set of items in transaction IDs. For example, customer buying milk and bread will tend to buy eggs and coke. So now let us figure out how can we find such association in a given data set. For this, we must know what is an item set. An item set is a collection of one or more items. Example, a set of items containing beer, diapers, and bread. To figure out the popularity of an item, to figure out how frequently it is being purchased, we use support count, which is denoted by sigma. As we can see, the support count for the set of items containing bread, milk, diaper is 2. This set can be a subset of a larger set containing these items. The fraction of transactions that contain this item set is 2 upon 5 if we consider these 5 transactions. That is, out of 5 transactions, only 2 transactions have this subset. Based on the data, we define a minimum support threshold, which can be any percent like 40%, 30%, and we say that any item set above that particular threshold is a frequent item set. These values help us to derive an association rule. An association rule is an implication expression of the form X implies Y, where X and Y are an item set. Here, both X and Y need to be a frequent item set by themselves to give a proper association. That is, the support value of the item set must be above the minimum support threshold. Secondly, in the most of the transaction where X appears, Y should also appear. This provides the confidence. This increases the accuracy of the derived association. Here we can see the support for milk, diaper and beer for the total set is 2 upon 5, that is 0.4, where the confidence for them is 2 upon 3, which is 0.67, which implies that the given association rule is true for the 40% of all transactions with 67% of accuracy. If this is about the minimum support threshold and the minimum confidence threshold, then this is a valid association rule. Now there are two ways to calculate these values for the dataset. First approach is a brute force approach, where we list all the possible association rule, then we compute the support and confidence for each rule, and then we eliminate the rules that fails because they are lower than the minimum support thresholds or minimum confidence threshold. This method is computationally expensive because this requires too much of calculation and it is not feasible for large datasets. Another way is to use a bottom-up approach. A priori algorithm is an algorithm for mining frequent item set from large relational databases. A priori algorithm was proposed by Agarwal and Srikanth in 1994, and it was designed to operate on database containing transactions. It proceeds by identifying frequent individual items in a database and extending them to a larger and larger item set as long as those item set appear sufficiently often in a database, eliminating non-frequent datasets. Now let us look at some area where association rule mining has helped a lot. First is market basket analysis. This is the most typical example of association mining. Data is collected using barcode scanners in supermarket. This database, known as market basket database, consists of large number of records on past transactions, a single record list of all items bought by customer in one sale. Knowing which group are inclined toward which kind of product allows shopkeepers to adjust their store layout and the catalog optimally. Another area is medical diagnosis. Association rule in medical diagnosis can be useful for assisting physicians for curing patients. Using association rule mining, we can identify the probability of occurrence of illness concerning various factors and symptoms. This is a first step towards personalized diagnosis and medicine. Earlier, it was believed that amino acids in a protein sequence occur independent of each other, which is now believed that they aren't. Researchers now say that every amino acid has a propensity score for its occurrence in a sequence after a certain amino acid. Knowledge can come handy during synthesis of artificial proteins. The association rule mining also helps in the study of genetics of co-expressing gene and co-regulating genes, where we can check their confidence value and support values across the genomes.